Okay, so our very last example of two paired means, or two paired samples, is going to be a hypothesis test. And this is probably one of my favorite examples of the class because it's so silly. But it says you've got a statistics class and students took their pulse rates before and after being frightened. So right here, the before and after is what leads this to be a paired sample, which I spelled incorrectly. See, I even type incorrectly, but that's okay. The frightening event is the funny part. It was having the teacher scream and run from one side of the room to the other. So apparently the students did not realize this was going to happen. The teacher handed out the stopwatches, said take your pulse rates, and then all of a sudden ran screaming from one side of the room to the other. And that was the frightening event, and then had the students take their pulse rates after that happened. It was also apparently a class of only men, so that's something to note. So we're going to pull those up in StatCrunch. They're actually from our textbook, so we'll pull those up in just a second. We're going to treat it as though it was a random sample of male community college students. We're going to test the hypothesis that the mean of the college men's pulse rates is higher after a fright. So would this be true for all college students is the idea. Is there any evidence that after a fright their pulse rates would be higher? We are going to have to decide which is sample 1 and sample 2, so I'm just going to let before be sample 1 and after be sample 2. That seems logical. I'm going to write my hypotheses. So my null will be that they're the same, that the mean before is the same as the mean after. But in StatCrunch formatting, the way you'll see that is before minus after equaling 0. They're the same. You should be able to subtract them and get 0. And we are specifically looking for, is it higher afterwards? So be careful, because just because it says higher doesn't mean I'm automatically going to use a greater than sign. We want to know, is the after higher? So in this case, because of what I chose as 1 and 2, I actually need to use the less than symbol. And that's going to matter because that's a symbol I have to choose in StatCrunch when I get there. Okay, so we are good on, yes, this is a paired test. I basically need to now get into StatCrunch and have it tell me this t and this p-value in order to continue. So when you're pulling something open from your textbook, we want 9.70. When you do the main StatCrunch tab, you have the from your textbook option. So then we can go to 9. It's an exercise, and it's number 70. So certainly pause if you need to for that. But once you've got it open, now this is different. We have actual data for this. We have all of the before and all of the after measurements. So this is one of the very few times when we go in and we go to T-Stats and you choose paired. Notice it doesn't even give you an option for do you have data or do you have a summary. Anytime you're doing the paired data, you will have actual data because they've got it paired up, right? When we were looking out here, notice every before and after, we know that is a single person, so it's paired up like that. So they have to give you the data in that format. So when you go under paired, you just have to be able to tell them which one's your sample 1. So our sample 1s were before and sample 2 was after. And then I just need to make sure my hypothesis test looks right. So again, you're going to see that difference score there. So my null was that they would be the same. So that would be that if I subtracted them, I would get 0. But my alternate was that if I subtracted them, I would get something less than 0. So I do need to change that. Then I can compute. I can note my t-stat and my p-value and come back over. So my t-stat was negative 0.64 approximately, and my p-value was 0.2712. And based on that, what's my conclusion? Well, since the p came back actually much bigger than alpha, much bigger than 0.05, we're going to fail to reject the null. So we're failing to reject the idea that they are the same. So we can just simply say the pulse rates, or the mean pulse rates before and after a fright are the same. Or we could kind of say that in the other version, where we say something like, we didn't find any evidence, or find enough evidence to say the mean pulse rate is higher after a fright. You don't have to write it out both of those ways, but that's just both ways that you could interpret it.